Hello, it's Mrs. Trombley coming at you with a crash course in probability. So in our textbook, probability happens in chapter 9, and today we're going to just do a quick run through of what's covered in sections 9.1 and 9.2. So as part of your skill assessment grade, you do need to write down everything I write down, so I know that you watched this. Don't just copy off your friends, write it down. The words that I'm saying need to be understood too, not just the things that I'm writing. All right, if you want to follow along, we're in pages 386 to 393 today. You can kind of look back as a guide if you'd like, but I think this should do it. Okay, so in section 9.1 and 9.2, we talk about just general probability, what it means, and then focus on experimental probability. So I'm going to define a whole bunch of words for you, and then we'll apply it so you know what those words mean. First off, an experiment, it's an activity with varying results. So the results aren't always the same, they change or vary. The possible results of an experiment are called outcomes. So things that can happen as a result of what you do. A collection of outcomes is an event. The outcome of a specific event, the outcomes of a specific event, are called favorable outcomes. So an example of all that, because it's a lot of words. Let's say you have this bag of marbles. This is a fun experiment, let me tell you. Anyway, let's say you have a bag of marbles. Randomly picking a marble from a group of marbles is called an experiment. So that's the thing you're going to do that can have different results because you have different marbles in there. Each marble in the group is an outcome. It's a possible result. It's what you could pick out of the bag. Selecting a black marble from this group of marbles right here that you can see, selecting a black marble is an event. All right, and then the favorable outcomes will be picking what you actually wanted. So take a look here. Let's say there are 6 marbles in a bag. There's 2 black, there are 3 gray, and there's 1 white marble. These are all the possible outcomes because those are all the marbles in the bag. The event that I want is I want to choose a black marble. And in looking at this bag, the favorable outcomes are 2 because there are 2 black marbles. So hopefully all those words make sense. Next, probability. The probability of an event is a number that measures the likelihood that the event will occur. Probabilities are between 0 and 1, including 0 and 1. Examine the diagram. So basically what's going to happen here is you're going to end up telling me the probability of something happening, and your answer is going to be written as a ratio, as a fraction, and that fraction tells you the likelihood of that event happening. So for example, we have impossible, that's this 0. Let's say I said, what are the chances you picking a purple marble? 0 out of 6, right? Because there aren't any purples. So the likelihood of that would end up being 0. Or as a decimal, 0. Or as a percent, 0%. All right, let's say that the chances of drawing something out were equivalent to 1/4. So there's a 1 out of 4 chance that that event's going to happen, or 0.25, 25 hundredths as a decimal, or 25% as a percent, because they're written all 3 ways. Whenever you see the likelihood of an event, it can be written as a ratio, it can be written as a decimal, or a percent. So if something had a 25% chance of happening, you'd say that's unlikely. If there's a 25% chance of rain, it's more likely that it's not going to rain than that it is. Equally likely means that if you have a ratio, it's going to simplify down to 1/2. There's a 50-50 chance, right? So 50%, or 5/10 as a decimal. If, after you simplify your ratio, it comes out to be 3/4, somewhere around there, 0.75 or 75 hundredths as a decimal, or 75%, that means it's likely that it's going to happen. It's not 100% sure, but it's pretty likely. So if there's a 75% chance of sunshine, I'm going to assume that it's most likely going to be sunny out. And then we have certain, meaning what's the probability of drawing a marble out of a bag of marbles? Well, 100%, because there's all marbles in there, unless you lost your marbles like me. I lost my marbles a long time ago. Haha. Anyway, so if an event is likely to happen, 3/4, if it's certainly going to happen, meaning there's no other possibility, it's for sure, then it's a 1 or 100% if you had changed that 1 into a percent. Okay, So now we're going to talk a little bit about theoretical probability. It's nice. So far you haven't had to write anything down. See why it's important to watch this? You're getting all kinds of good information. When all possible outcomes are equally likely, that falls into this category here. The theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. An experiment is fair if all of its possible outcomes are equally likely. So when I say equally likely, think of if you flip a coin, you don't have a better shot at getting heads than you do tails, right? You have a 50-50 chance. That's what I mean by fair. Or if you roll, they call them number cubes a lot in what you read. I call them die, or the plural dice. If you roll a die, it has 6 sides, the numbers 1 through 6. You have an equal likelihood of rolling a 1, the same as you would rolling a 5. Each number has the same. So that's what's considered fair. If your chances are better at something than others and it's not a 50-50, that's when it's not fair. And we hear that all the time. It's not fair. All right, so what this means here, P and then event, it means the probability of whatever event we're talking about. All you have to do to figure out the likelihood of an event, to get this ratio so I know how likely it is to happen, is you take the number of chances that it could actually come out in your favor. And you divide that by, or put it over top of, how many possible outcomes there are. So I'll show you an example of what I mean here. We actually get to write something down now. So if you have, a pencil handy, you need it. Finding a theoretical probability. So you randomly choose one of the letters shown in this word explore. I want to know what the theoretical probability of choosing a vowel is. So the formula for theoretical probability here is you take the number of favorable outcomes over the number of possible outcomes. So I know I'm going to have a little fraction here. I'm going to draw my bar. Okay, so theoretical probability of choosing a vowel. The number of favorable outcomes, that's the number of chances I have to actually draw out a vowel. So if you look through these and you pick out the vowels, there's one, and there's one. So there are 3 vowels. There's 3 favorable outcomes. And then you're supposed to divide that or put that over the number of possible outcomes. So that includes the total number of events here. So there's 1, 2, 3, 4, 5, 6, 7. So 3 out of 7. Now in terms of figuring out the likelihood of this, if we looked back up at that little chart, 3 7s I don't see on here. It might be a little easier if it was a percent. Do you remember how to change 3 7s into a percent? Top divided by bottom times 100. That's what you always do on your little quizzes to figure out what you got. And if you change this to a percent, it's about 42.9%. So all I did was 3 divided by 7 times 100. Sorry, I'll make that a little better. To get 42.9%, or about 43%. So in terms of up here, that would fall in here somewhere, right? So it's between unlikely and equally likely, but it's on the left side of the equally likely. So it's less likely to happen than is to happen. So that's how this number here fits into that little chart. Okay, a couple more little examples, so turn your page. Okay, you're going to be shocked at what we have to do with this one. Let me tell you. Okay, using theoretical probability. The theoretical probability that you randomly choose a green marble from a bag is 3/8. There are 40 marbles in a bag. How many are green? Okay, now I want you to look at this problem, and I want you to look at the information that you're given. Okay? You're given a ratio and one other number. What do you do to solve things when you're given a ratio and one other number? Please be shouting out a proportion at your computer right now. We set up our proportion. And we start off our proportion with the ratio that we're given, which is 3/8. So these are the chances of picking a green marble out of the bag. So here's the green, and here's the total numbers in the bag. Now if I tell you there are 40 marbles in the bag, how many are green? The chances that you're going to pick the green are 3 out of 8. That means this 3 represents the green, right? And this 8 represents the total. So if I tell you there's 40 marbles in the bag, that's going to go across from the 8 because that's the total. I'm asking you how many are green, so that needs to go across from the green. I am quite certain you know how to solve these, probably in your sleep. So let's cross multiply to make our one step. 8 times g is 8g. 40 times 3, I would just do 4 times 3, which is 12, and then add a 0. It's a nice little trick. And divide by 8. And when you take 120 divided by 8, you get 15. So if the probability that you're going to pick a green marble from a bag is 3/8, that was simplified, and there are 40 marbles in the bag, 15 out of those 40 would be green. Which, by the way, you know how you always give ratios in simplest form? That's what you did all through our last chapter, chapter 5 that we covered. Yeah, you need to make sure you do the same thing. So when you're figuring out the likelihood of something happening, let's say the likelihood of something happening was like 4/10. You would want to simplify that to 2/5. So you're still always giving your final answer in simplest form. All right, one last little bit and then we'll be done. Is it fair? We talked about fairness, and we said that fairness happens when each event is equally likely to happen. So you have a 50-50 chance. So a number cube is rolled, a die, that's what it's talking about. Determine if the, couple typos on mine, but they won't be on yours. Determine if the game is fair. So when you're trying to figure out if something is fair, you basically have to look at what are the chances that I'm going to win, and what are the chances that the other person's going to win. And if you both have the same chance, then it's fair. If one of you has a better chance at winning, then it's not fair. So take a look. A number cube die, and it says you're going to win if the number is odd. Well, when you roll a die, it's 6-sided, right? So your chances are 1, 2, 3, 4, 5, and 6. Those are the numbers that you can roll, right? So you win, so I'm going to write U here, if the number is odd. So if you roll a 1, a 3, or a 5, those are the odd numbers, then you win. So we said that the theoretical probability is the number of favorable outcomes, 3, over the total number of outcomes, 1, 2, 3, 4, 5, 6. And we're going to simplify that, of course, and that simplifies to 1/2. So that's you. Your friend wins if it's even. So your friend can win if it's 2, 4, or 6, right? That's also 3 out of 6, which is 1/2. So if you both have a 50-50 chance at winning, you both have the same ratio, then yes, this is totally fair. That game is just fine. You could take a look at this example. With this one, you win if the number is less than 3. So here is you, and we'll write friend over here. Okay, so you win if the number is less than 3. When you look at these numbers, same thing, 1, 2, 3, 4, 5, 6. The number of numbers less than 3, there are 2 numbers less than 3, right? So that's the favorable outcomes over 6 total. So your chances of winning simplify to 1/3. If it's not less than 3, your friend wins. So not less than 3 includes 3. 3 isn't less than 3. So 1, 2, 3, 4 numbers are favorable out of the 6. So your friend has a 2/3 chance at winning. Are those the same? Nope. Your friend has a better chance at winning. That's not saying it's impossible for you to win, but your friend has a much better chance. So this is not fair. All right, that should be enough information for you to complete the rest of your skill assessment. See you later.